In this video, we're going to explain in detail how to control relative humidity inside a cold storage room or any refrigeration system designed for preserving meat and fruit. To begin with, we must understand that the preservation of fresh food does not depend solely on keeping it cold, but on a delicate balance between three fundamental variables: temperature, humidity, and air movement. When these factors are not properly controlled, even in a powerful refrigeration system, the result can be weight loss in products, surface dehydration, texture changes, and even deterioration in the commercial quality of stored meat or fruit. Within this process, the evaporator plays a central role. This component is the coldest point of the refrigeration circuit, and by cooling the air circulating through the chamber, it condenses part of the water vapor contained in it. This phenomenon causes a decrease in the relative humidity, RH, of the environment. As the air loses water vapor due to condensation on the evaporator, it becomes drier, while the surface of the food continues to maintain a higher vapor pressure. This creates a vapor pressure imbalance. Moisture naturally flows from the food toward the air in an attempt to reach a new equilibrium. In practical terms, this means the food begins to lose water through evaporation or even sublimation under freezing conditions. The effect becomes more intense when the evaporator temperature is too low compared to the air temperature in the chamber, which we know as a high temperature differential, delta T. Under these conditions, the air dries out more quickly, and the relative humidity drops significantly. The result is a much harsher environment for stored products. Meat, for example, experiences a surface moisture loss that translates into dehydration, weight loss, and sometimes darkening or hardening of its outer layer. For fruits, overly dry air can cause wilting, loss of juiciness, and a shorter shelf life. On the other hand, when the temperature differential between the evaporator and the chamber air remains small, the air retains a high relative humidity, generally in the range of 90 to 95%. This level is considered optimal because it significantly limits water migration from the product to the surrounding air. For instance, technical studies have shown that with a delta T of only 5 degrees Celsius, the weight loss of fresh meat can be reduced to less than 1%, whereas with higher differentials, that loss can multiply 3 or 4 times in just a few days.